Hello everyone, I'm Kavita Sanghvi and I'm very honored to present a research paper on STEM education. So we are aware that the world is confronted with numerous global issues such as poverty, climate change, terrorism, gender equality, human rights issues. Now, to address these problems, we really need to have innovative solutions and integrate knowledge of STEM disciplines which can support the construction and implementation of impactful results. We have to begin at school level, and who can do that? Only our educators. So thus, I created a course, Build a STEM Competency course of four modules extending over 5 weeks so that it could help teachers enhance their STEM knowledge and skills. And this paper is to study the impact of the STEM OER course on enhancing teachers' STEM knowledge and skill competencies. Now, what does STEM actually mean? It's an acronym for Science, Technology, Engineering and Mathematics. It is also called a STEAM when you integrate arts, and STREAM when you integrate even research into it. So STEM education is an approach that eliminates the boundaries between disciplines by enabling students to understand the world as a whole rather than parts. Now, why is it so important for us to go in for the study? Well, do you remember your classroom days? Do you remember when you were using pencils in our school days? But we often use the pencil called as H pencil or B pencil or HB pencil. Have you ever questioned what is this? Well, your H pencils don't leave much graphite behind on the page, making your writing very light. Your B pencils are soft and leave a lot of graphite on the paper, making the writing very dark. And the combination of HB uses the strength of both the H and the B pencils, making it ideal for writing. But did we ever question this? Never. So this is the reason we need to go for the why when we are doing in schools. And this is what teachers need to equip the students. Why are we using an HB pencil? For what reason? So this is the need to bring in STEM education within our classrooms. So we've started giving this course out, the significance of this course. Now, this STEM OER course is going to be based on building STEM competencies in the teachers. When we talk of competencies, we talk about knowledge, skill, and attitude. Now, this course, when it talks about knowledge, it will be talking about building the epistemology knowledge, the procedural knowledge, the technical knowledge of the STEM topics covered in the OER course. When we talk about skills, then we're talking about critical thinking, problem solving, collaborative, communication, digital skills, and analytical skills. And we're talking about attitude, is the values, the STEM values that we're talking about. When we talk about a literature review, well, Halliburton in 2024, he actually highlighted the use of maker spaces to build confidence in STEM among pre-primary, pre-service teachers. And he had taken 240 teachers who were divided into groups to create STEM kits for their schools. And when he worked on them and he sounded from the results, he saw that collaboration was seen as a key factor in boosting confidence among the teachers. The research also underscores the potential of maker spaces to enhance the teachers' confidence in STEM. Thus, it's very important that we use certain kind of maker spaces for schools also. Anita had done a research and she was exploring STEM teachers' motivation and engagement in professional development and career advancement. So, certain findings that she had across reviewing all the career documents, that 80% of teachers view collaboration as essential, but yet face challenges such as communication difficulties, lack of trust, and time constraints. 60% reports challenges in implementing STEM reforms and technologies in classrooms, and 70% of teachers are interested in non-traditional educational roles. Thus, her research said that collaboration is very important to improve work-life balance. Now, what was the aim of this study? It was to design a STEM OER course for students, teachers, to study the effectiveness of this course in the STEM teachers to make sure that their competencies are improved for classroom teaching. So, when we talk about the objectives and the hypothesis, we had actually a control group and an experimental group. So, the hypothesis was basically understanding whether there's any difference in the pre-test and post-test of control group, pre-test and post-test of experimental group when it came to STEM competency and the STEM knowledge quiz. Also, the difference in pre-test and post-test between control and experimental group. Difference in post-test of control and experimental group. So that was the hypothesis, whether there was any kind of significance difference. This hypothesis was also to understand whether there's a relationship between the task course and post-test STEM competencies in teachers from the competency group, from the experimental group. Also, to understand the relationship between task course and post-test STEM knowledge scores in teachers of the experimental group. So we also studied the results, the relationship, and also whether there was any kind of a gain score of building STEM competency as a part of OER. So this is how the design of the OER course is. The course is called Build Your STEM Competency. It's got 4 modules. The first module dealt with knowledge of STEM education, STEM is everywhere, need for STEM education. Module 2 dealt with integration of STEM disciplines to real-life problems, strategies and methodologies to enhance STEM learning within the classrooms, and introduction of a STEM lesson plan where teachers will actually try to write a STEM lesson plan for their own classrooms. The third module dealt with exploration and experimentation in STEM classroom teaching, enhancing STEM competencies to technologies, and building STEM skills. The fourth module spoke about a variety of assessments to evaluate STEM competencies in teachers and students. How do you go about assessing students? Building STEM attitudes and ethics. And how do you integrate STEM and SDG? Because SDGs are so important. And finally, feedback and closure. And thus we had 11 tasks across the entire modules to assess the task course and to see whether teachers are developing competency. So task 1 is about sharing perspective. Task 2 was sharing a video and audio about how they would integrate STEM into everyday activity. Task 3 was going through UNESCO articles and noting down concepts of STEM. Task 4 was a game in STEM. Task 5 was talking about climate change and how would you understand STEM principles in climate change. Task 6 is using STEM concepts to solve real-life problems. Task 7 is what is their plan of action if they were come up with any kind of situation which required them to use the STEM skills. Task 4 was to design a 1-week STEM course for their own classroom. Task 9 was to see movies, study movies, and understand any STEM concept of that movies which they could integrate within their classrooms. Task 10 was to create a video of themselves using any app and share it. And finally, Task 11 was to create their own lesson plan and design it. Now, what is the methodology that I used across for my entire research? Well, a quasi-experimental quantitative design was deemed most appropriate, where we had an experimental group which underwent the entire course and a control group. So in the experimental group, we had a pre-test where the STEM knowledge was taken, test was taken, a competency test was taken. The treatment was offered to them, this entire course, and also synchronous weekly online meetings. And post-test, we had the course task, again a STEM knowledge test and a STEM competency test. In the control group, we only had a pre-test of knowledge and competency and a post-test of knowledge and competency. Now, what are the tools which we used across to assess this? Well, we used a self-assessment tool from Teach STEM. Now, in this Teach STEM, the teachers right across, there were many questions, around 35 questions, they responded to it, and then they got a complete report on their STEM competencies. And a STEM quiz was taken from Silver Zone Foundation STEM Olympiad sample test paper, and the teachers gave attempted questions based on that. So this is a kind of question that the teachers based, making sure that entire science, technology, engineering, mathematics, all the fields were covered. And then validity and reliability of both the tests was conducted. So in the first case, when you did the STEM competency, the entire validity The test-retest correlation of 0.7613 indicates a very good reliability, that the test is stable and reliable. Then also system knowledge. Just understand, again, the reliability is there, the validity is there. So we got a reliability coefficient of 0.8375, and the tool is consistent in measuring the intended construct. We come to data analysis, and we use Microsoft Excel to record the test scores, competency scores, and task scores of participants. It is also used for data manipulation analysis. And when you look into the entire graph out here, you see that there is STEM competency control pre-test and control post-test. Now, if you see the kind of analysis done out here, you realize that in the first case, the null hypothesis is accepted. That means there was no change because the calculated t-value is less than the critical t-value. In the second, when we talk about STEM quiz, control pre-test and control post-test, again the hypothesis is rejected because here the STEM knowledge quiz control group is minus 6.064, and the absolute value is greater than the critical t-value at 0.001 level. So therefore it is accepted. The hypothesis is rejected. In the third case, when we went into STEM competency between experimental pre-test and post-test, well, the t-value is minus 4.741, and it is greater than the critical t-value at 0.05 level and the 0.01 level. Therefore, the null hypothesis was rejected. In STEM quiz between experimental pre-test and experimental post-test, the t-value for control and experimental competency is minus 10.295. Again, it is much greater than the critical t-value at the 0.01 level, and thus it is once again the null hypothesis is rejected. There has been a difference. Now when we come to the next one, we do between control and experimental group, and again we're talking about STEM competency with pre-test and post-test. Now in t-value for control and experimental competency pre-test is minus 1.987. It is less than the critical value at the 0.01 level, and thus the null hypothesis is accepted. When we go on for STEM competency at control post-test and experimental post-test, the value is minus 5.089, which is greater than the critical t-value at the 0.01 level, and thus the null hypothesis is rejected. When we talk about STEM quiz between control and experimental pre-test, the t-value is 2.987. The result is statistically significant at both the 0.05 and 0.01 level. Therefore, again, the null hypothesis is rejected. When we come about STEM quiz, again between control post-test and experimental post-test, it is minus 0.138. It is very much less than the critical t-value at the 0.01 level, and thus the null hypothesis was accepted. Now, when we study the relationship between task scores and STEM competency in experimental group. In this case, when you see the relationship, you notice that the R value is 0.436 and is a moderate positive correlation. Therefore, null hypothesis is rejected. When we come across for STEM task or STEM quiz, the R value is 0.441. It is a moderate positive correlation, indicating a moderate relationship between task scores and post-test knowledge quiz. Even the graphs can show the relationship. So we already spoke about the relationship between task course and STEM competency and experimental group. Now this is exactly the graph for the second part of this task course STEM quiz, where we show the relationship as R value as being 0.441. Now let us talk about the gain score and STEM competencies among teachers in control and experimental group. Now if you look out here in the first part when we talk about STEM competency between control and experimental group, we see that the score, T-score is 2.597. Now this critical T-value is greater than 2.034. Therefore, we reject the null hypothesis at the 0.05 significance level, but it is not greater than at 0.01 level, that is 2.733. So at that level, we accept the null hypothesis. Now when we talk about STEM knowledge quiz, the t-value is 3.075, which is greater than both the t-value at 0.05 level and at 0.01 level, and therefore we reject the null hypothesis and there has been a gain. Now this gain is also shown to you in terms of the graphical data. Now we also speak about the effect size of the OER course treatment on building STEM competencies among school teachers in the experimental group. Now when we saw out here, we see that the calculated t-value is minus 10.295, which is there's a huge significant difference between the pre-test and post-test scores of the experimental group, and thus this is not due to random chance. And this means that the experimental intervention has a strong and statistically significant impact on the STEM knowledge quiz course, and this shows that there has been a good effect of the OER course on the experimental group. When it comes to STEM competency test also, we see that the t-value is 4.741, which is greater than that. So therefore, the effect size of 0.777 is considered a medium to a large effect. And effect size measures the magnitude of the difference between two groups, and thus it is pretty good. So again, the null hypothesis gets rejected. So when we come to conclusions, well, we notice that the experimental group has got a significantly higher average score, gain scores 3.902 compared to the control group, which is 2.3, indicating that the intervention led to a significant improvement in the STEM knowledge quiz scores for the experimental group when compared to the control group. In terms of STEM competency, observe that the difference in gain scores between the control group and the experimental group is statistically significant at the 0.05 level. Since the t-value is less than 2.733, we did not reject the null hypothesis at the 0.01 level. So this means that this course has been effective in building STEM competencies among teachers in the experimental group, and we would request more people to experiment with this course and share their data with us so that we know that this course we can know the significance of the course and how to make it even more robust and meaningful for the teachers to take it back to the classroom and ensure that STEM is something which is part and parcel of the entire curriculum transaction. Thank you so much and have a great day.